apart from tetrahedral geometry, another possible geometry for methane is square planar, right? With 4 H atoms at the corners of the square and the carbon atom at its center. Lovely. Explain why methane is not square planar. Beautiful question. Why should methane not be square planar? Because, even square planar is a very symmetric structure. Let me draw for you, just for a moment, a square planar structure. So imagine this. And you have hydrogen, 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 and hydrogen like this, right? And this is, of course, your carbon atom, no doubt. Now, in this square planar structure, do you notice that the bonds are at 90 degrees angle? Okay, so all the bond angles are, yes, all the bond angles are 90 degrees. The adjacent ones are 90, and even this, if you observe between this and this, it would be even 180 degrees for that matter. It would look like as if, fine. Now, what does VSEPR theory say? VSEPR theory says that the atoms within a molecule repel each other and they try to arrange themselves as far apart from each other as possible. They try to arrange themselves as far apart from each other as possible, right? And let me see, if this is the CH bond length, and let me say that a CH bond length is L, so the distance between adjacent hydrogen atoms will be L root 2, thanks to our good old Pythagoras. If the distance between CH, that is CH bond length is L, then the distance between the H atoms would be L root 2, in case the structure happens to be square planar. Now let us say that the structure changes to tetrahedral. Can we just change this? Let me just draw a diagram in case the structure changes to tetrahedral, maintaining the same bond length of CH. So we have CH, we have a three-dimensional structure in which one atom comes outside the board plane, one goes inside, and two of them remain in the same plane. And if you join these, joining each of them would give you an equilateral triangle like this and like this. This is a tetrahedral structure, right? Right? If you try to find out the bond length now, first of all, what is the bond angle? Well, the bond angle will be, each of these bond angles is 109 degrees, 28 minutes. Oh yes, yes. And if you find out, or if you try to find out, so this is length L, this is length L, what would be the HH bond distance? Can we find out that? Yes, we can. And if we find that this HH distance is longer, bigger, then this is much better as per VSEPR theory. Why? Because Vesper theory said that atoms within a molecule which are attached to central atom, they repel each other and they try to move as far apart from each other as possible. So let us see, have they moved far apart enough? If they have, then we have the answer. This calculation might look a little complex to you initially, but if you're just careful with me, we will make it very easily. How? Just let us first see this, and let me drop a perpendicular here. If I drop a perpendicular, it is going to touch the equilateral triangle at the bottom at centroid. Okay, so just for the sake of clarity, let me draw this triangle again here. H, H, H. This triangle, I'm looking from top, and this is what I'm seeing. This is centroid G, if you might call it G, fine. I'm interested in finding HH bond distance. This is what I feel like finding out. And what all do I have? Well, there are a few numbers I'm supposed to get. So this is, of course, if I draw like this is the triangle I'm emulating here. This bond angle is 60 degrees. So this is, of course, equilateral triangle to 60. So this is 30 degrees. So this is a 30, 60, 90 triangle. Yes. Okay, fine. But what are you trying to do? I am just trying to find out this distance. If I find out this distance, I'll double it and I will get the entire HH bond length. But you might say that I don't know this or this distance either. In that case, we should make efforts to get those distances. And how do we do that? We will look at this triangle also. This is getting complicated. Well, this is what NCERT demands. The true answer will be when we derive this. But we wanted easy answer. So you just skip the derivation and take the final answer. You can also do that if you just want to do it in a shortcut. But I'm trying to explain it fully. So what I'm going to do is H. This is H, this is G, and this is H. This is where I had my carbon atom C. And this GH is the distance. This GH is the distance I am very keen to find. Right? GH. How would I do that? This distance is HH. Yes. This is 90 degrees angle. Yes. Do I know anything about this so that I can find out this? I think we might know this. Why? Because we know very well that this angle, HCH angle, this is 109 degrees, 28 minutes. Let's do the calculations. Just a little patience and we'll get there. See, this CH distance, say this is L, this is what we said. So this is also L. And let me tell you the result for a tetrahedron. In a tetrahedron, if you are sitting at the very center of tetrahedron, then this line, this entire line, it will be divided in the ratio 3:1 by this carbon atom. This is the property we are borrowing from geometry. That means if this is L, then this distance CG will be L by 3. Okay, this right angle triangle, if you see this is L, this is L by 3. How much is this? This is root 8 by 9 times L. Jai Pythagoras, GH. This GH we have just got. And cos 30, which is root 3 by 2, which is equal to this distance. Let us call this distance D. Then D upon GH. And GH is L root 8 by root 3 is actually, sorry, root of 9 would be 3. I'll just use 3 here. Can I find out D? Yes. Therefore, D is root 3 upon 2 into root 8 is 2 root 2 upon 3, which is root of 2 by 3. This is the distance D. The HH distance is L root 2 upon root 3 into 2. I'll write it again. L into root 2 upon root 3 into 2, like this. Why? Because this is half. Full HH distance will be multiplied by 2. This distance was L root 2, right? And this is L root 2 into 2 upon root 3. Root 3 is 1.732. I hope you can see that this 2 upon root 3 is more than 1, which means that this HH distance in tetrahedron is longer. Hydrogens are separated by a greater distance in a tetrahedron as compared to square planar. And that is why, as per Vesper theory, the geometry changes to tetrahedral and not to square planar. If you want to do this short, you might say that, sir, you have presented such a long and messy solution. You can just memorize this result also. If you're not happy with, such long and complicated and convoluted calculations, yes, we are very unhappy. You have made a simple question very dirty. I have not done this. But I could give you another result. Say, if you have C, H, 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 H. What is this? This is tetrahedral structure. And you could say that is there a relationship between CH bond distance and HH distance? Yes. If CH bond length is L, if CH bond length is L, then HS distance is 2 root 2 upon root 3 L. You can take that as a standard result for any tetrahedron, right? If you take this as a direct rata-rata result, you get this separate. But how did this result come? I have just derived and shown you entirely in the full exhaustive way. Otherwise, you can use this result directly also. Does it have to be mathematical? This is a very beautiful and accurate solution to this problem. However, considering this is only CBSE or NCERT, if you want to simplify this, you could say that HS distance increases if the structure becomes tetrahedral. So, as per Vesper theory, tetrahedral is more favored as compared to square planar. That also would be okay. That's fine.